All right, we're looking at example 3. Example 3 of we're using system of equations to answer word problems. So example 3 is Ann and Betty together have $60. So they have $60 between the two of them. Ann has 9 more than twice Betty's amount. How much money does each have? So same as the first two examples, we are going to define the variables. Typically, the easiest way to figure out what the variables should be is what are we trying to figure out? We're trying to figure out how much money each has. So I will let X equal the amount of money Ann has. I'm just going to write Ann's money to save some time here. So then Y would equal Betty's money. So X is how much money Ann has, Y is how much money Betty has. Our first sentence says together they have $60, so that looks like that's going to be my first equation. I know Ann's money plus Betty's money has to equal 60, and that gives me equation number 1 of the 2 equations I need to come up with. So X plus Y equals 60. So now what I'm looking at is, okay, I need a second equation. This one's definitely trickier than the first 2 examples. So I'm looking at that second sentence. Ann has 9 more than twice Betty's amount. So our first key word here is Ann has. Ann has. So if I said Ann has $10, you could say Ann equals $10. So if Ann is X, I'm going to say X equals. And it equals 9 more than twice Betty's amount. So 9 more than twice Betty's amount. Twice Betty's amount, well, I know Betty's amount is Y. We already said that. So twice Betty's amount would be 2Y, and then it's going to be 9 more than that. So 9 more than that, I got to add 9. So twice Betty's amount plus 9 would equal Ann's amount. So now I've got my 2 equations. And I got to figure out how to solve them. We've learned 3 methods: graphing, elimination, and substitution. Graphing, obviously not a good idea. So the first 2 examples we did the elimination method, but this one, they're not lined up like they are. I mean, I know the X and the Y are kind of lined up, but my equal sign is here. That's not going to work. But I look at this, I know X equals 2Y plus 9. This would be a great substitution method problem. So what I can do is, if I know X equals 2X plus 9, or X equals 2Y plus 9, sorry. So if X and 2Y plus 9 are the same thing, I can take a 2Y plus 9 and substitute it in for this X. So when that first equation is X plus Y equals 60, what I can do is, in place of the X, I can put 2Y plus 9, because those are the same thing. I know that because of this equal sign right here. X equals 2Y plus 9, so they're the same. So I put that in place of the X, I still have a plus Y here, and it still equals 60. So now I'm going to solve this equation, 2Y plus 9 plus Y equals 60. Remember, first thing I'm going to do is combine my like terms. 2Y plus Y is 3Y, that's plus 9, which equals 60. I'm going to move that up here. So that's 3Y plus 9 equals 60. That's just a 2-step equation. Step 1, subtract 9. I've got 3Y equals 51. Step 2, divide by 3, and I figure out Y equals 17. So I figured out Betty's got $17. So now I can figure out Ann's amount by just plugging it in. I'm going to plug it into the first equation. X plus Y equals 60. In place of the Y, I'm going to put 17 because Y equals 17. So then I solve that to subtract 17, and X equals 43. And now we figured out that Ann has $43. So to answer the question, Ann has $43, and Betty has, what do we got? $17. And we've successfully answered this question. So step 1, we defined our variables. Step 2, we wrote our equations. Step 3, we solved. In this case, we solved by the substitution method because the problem was set up for that way, unlike examples 1 and 2, which were set up to definitely be solved by systems of equations. All right, that's example 3.